In today's lesson, we are going to be looking at how to find the zeros of a quadratic function. We're going to see that the zeros are actually the solution. We're going to see how to find the vertex and how to find the axis of symmetry. So let's get started. The zero of a function is an x value that makes a function equal to 0. Now that sounds kind of confusing, but basically when it says what are the zeros, you want to find where does it cross the x-axis. They want to know where are the ordered pairs where the y would be equal to 0. Where are the zeros? So right here on this quadratic equation, the parabola, you'll see right here that it crosses the x-axis at -2, 0. And it crosses right here at 3, 0. These are called the zeros because that's when y is equal to 0, and it crosses at -2 and 3. So this one has 2 zeros. It means it crosses the x-axis at 2 places. Sometimes with parabolas, there's only going to be 1 0, which means it only crosses or touches the x-axis one time. Right here is the only place where it touches or crosses the x-axis. That is at 1, 0. Again, here's where we call it the 0 because the y equals 0. So there's only one solution to this quadratic equation. Sometimes, if you look right here, this parabola does not touch the x-axis anywhere. So what are the zeros? What are the solutions to this? There are no zeros. So you can see that with quadratic equations, you can either have 2 solutions, 1 solution, or 0 solutions. So to practice that, let's look at graph A right here. How many zeros, when it asks that question, how many places would the order pair be 0 for the y? In other words, where does it cross the x-axis how many times? There are 2 zeros in that one. B, you will notice that there are 0 because it never touches the x-axis. How many zeros are there in C? There is only 1. So you should be able to tell us how many zeros there are in a quadratic equation. And all that means is how many times does it cross or touch the x-axis. Now we're going to take it one step further, and we're going to identify the zeros in the following graph. Okay, so here there are, in the first graph, you will notice that there are 2 zeros, but what are they? Where do they cross? I don't know if that's ES or S. Not a good speller. You will notice that they cross the x-axis at 0 and 4. So we would say that the zeros are 0 and 4. That means that the solution to that is 0 and 4. In the second graph, we'll call this graph B. Identify the zeros. Where does it cross the x-axis? Nowhere, so there's no answers. On graph C, right here it touches. Where is that on the x-axis? It is at 3. So we're identifying, we're just telling where does it cross the x-axis? Where is that on the x-axis number line? Okay, now we're going to move on and talk about the axis of symmetry. If you remember in geometry, that symmetry is when you have an object and you can draw a line down the center of it and it's a mirror image on both sides. Like if this was a heart, you could draw a line of axis of symmetry and you could fold that heart and it would be the same on both sides. A parabola has an axis of symmetry. It's the vertical line that divides it into 2 parts. It is always going to pass through the vertex. So the question is what is the vertex? The vertex is always going to be the very highest point or the very lowest point. So when looking at this vertex, you will see that the very lowest point is right here. There's 1, 0, one solution. It's at 1, 0. So because this is on a graph, it's very easy to tell where the axis of symmetry would be because it's wherever the vertex is. So we can see that the axis of symmetry, I need to recalibrate my board, would be on 1. There's my dashed line to indicate the axis of symmetry that divides that into 2 parts. Now that was really easy because there was only 1, 0. It only touched the x-axis one place, so that is where the axis of symmetry is located. But what if it touches the x-axis at 2 places and you want to find the middle? Well, when you want to find the average of two numbers, all you have to do is add those two numbers together and then divide by 2. So if you look at where the zeros are, you will notice right here there is a 0 at -3 and there is a 0 at 2. So it crosses the x-axis at -3 and 2. So we're going to add -3 and -2 together. That is -1 and divide by 2. So basically you come up with a fraction, or if you wanted to convert that to a decimal, it'd be -5/10. So our axis of symmetry is -1/2, halfway between 0 and -1. So if there are two zeros, if it crosses the x-axis twice, you just find the zeros, add them together, and divide by 2. Okay, so let's practice here. Here we have two zeros, one at -1 and one at 2. So if we take -1 plus 2 and we add that together, you would get a +1. When you divide it by 2, you just get 1/2, which makes that axis of symmetry right there at 1/2. Here there is only one zero in graph B, if we call this graph B. And so the axis of symmetry has to be right there on 5. Now, if the function has no zeros or they are difficult to identify from the graph, you need to have a mathematical way to do it, because sometimes you don't have a graph and all you're given is an equation like you were given right here. Y equals 2x squared plus 4x plus 5. And if we were to say, where would the line of symmetry be? You need to find where the axis of symmetry would be. The axis of symmetry is always going to be equal to the x value, always where the x is. That's the axis is the x. That's easy to remember. Now, in doing this, there's a formula that always works. Here it is. And you're going to be using this formula a bunch in this unit. So you might as well start memorizing. It's -b over 2a, -b over 2a. And what does that mean? When you write the equation in standard form, the first coefficient is the a, the second coefficient is the b, and the third coefficient is c, which is really nice because that is your constant, c. So if we say that x is equal to -b over 2a, first we find the b, which is the number or the coefficient in front of the x, that's 4, but we want the opposite of it. So -b would be -4, and on the bottom we have 2 times the a term. Well, the a term is in front of the x squared, so that's 2, so we have 2 times 2. So if we solve this, -4 divided by 4, our axis of symmetry would be at -1. So we know now that on a graph that our axis of symmetry would be right here on -1. And all we had to do was use the equation -b over 2a to find where that axis of symmetry would be. Okay, you can always use this equation. So this is just more practiced. First, you need to identify what the a term would be, the b, and the c. Here's our a term. It's invisible in front, so it's a 1. So a equals 1. In this equation, b equals 3 and c equals 4. But all we need to know is the b and the a. So if we take the opposite of the b, that would be -3. And then 2 times the a term would be 1. So we have -3 halves, which is -1.5. So we know that on a graph, the line of symmetry would be at -1.5. -b over 2a is to find your x, your axis of symmetry. One more practice. Here, the a term is equal to 2. The b term is equal to 1, and the c term is equal to 3. So we're going to go -b, which is -1, divided by 2 times the a term. So here, you will see that the axis of symmetry is -1/4. So you can always do it mathematically. Now we're going to go one step farther. Once you find the axis of symmetry, you can use that to figure out the vertex. Remember, the vertex is going to be the very highest point or the very lowest point. And all that the vertex is an ordered pair. And that ordered pair needs an x and a y to get the vertex. Well, right here, when we use our formula of x equals -b over 2a, what are we solving for? We're solving for the x. So the first thing we're going to do is do our formula, figure out what x would be, and then we're going to plug it back in to find the vertex. So it would look like this. First, we look at our equation here. Our a term is right here in front of the x squared. It would be a -1. Our b term is equal to -2. And our c term is missing, so it is equal to 0. So to do our -2 over b over 2a, the opposite of the b would be a +2. And divided by 2 times a, which is -1. So we have 2 divided by -2, which is a -1. So we know now that the axis of symmetry would be right here at -1. But where is the vertex? Where is the highest point or the lowest point? We need an order pair. We now know the x. We know the x is -1 for our vertex. So we're going to simply plug that back in to our equation and solve for y. So our equation was -x squared minus 2x. When plugging in what we found x to be, which was -1, we have the opposite of -1 squared minus 2 times -1. Remember always to do this exponent first. So we're going to have the opposite of -1 squared. -1 times -1 is a +1, but we want the opposite of that. So that would be -1. And -2 times -1 is a +2. So we would have that y is equal to 1. So now we know y is 1, and we already figured out that x was -1/2. So now we know the vertex of this quadratic equation of the parabola that we're going to draw. It's going to be at -1, 1. So here's where the vertex is. We learned in the previous lesson to be able to tell whether this goes up or down. Since the leading coefficient is negative, we know that this is going to go down, so we know it's going to look something like that. We know where the axis of symmetry is, we know where the vertex is, and we know that it goes down. Okay, so let's practice again. First, we need to find the x, the axis of symmetry, using our equation -b. Whoops, I said -b and I wrote -2. We're going to use our equation -b over 2a to figure out where our axis of symmetry, or our x, would be. Here, our a term is equal to 5, our b term is equal to -10, and our c term is equal to 3. So negative, or the opposite of b, would be a +10 over 2 times a, which is 2 times 5. 10 divided by 10 would be 1. So we know the axis of symmetry. If we had a graph, our axis of symmetry is going to be x equals 1. Now, where is the vertex going to be? We're going to plug 1 back into our equation. And when we do that, we always evaluate our exponents first. 1 squared is 1, of course, so 5 times 1 is 5, minus 10 plus 3. And when you solve that, you get a -2. Y is equal to -2. So now we know the x and the y. There's supposed to be a negative sign there. That makes our vertex. So now we know that the axis of symmetry is on 1. The vertex is on 1, -2, which I'm going to say, whoops, my smartboard needs to be recalibrated, about there. And does this go up or down? Our leading coefficient is positive, so we know it's going to go up. So now we know a general idea of where it's going to be and what it's going to look like. Okay, one more practice. Again, we use the -b over 2a. So the opposite of b is 4 times 2 times a. So we have 4 divided by 2 is 2. If we plug that back in to find our y, we have 2 squared minus 8 minus 10. So we have 4 minus 8 minus 10, which would be a -14. So our vertex is 2, -14. So now we know that the axis of symmetry is at 2. The vertex is at 2, -14. And we know that it's going to go up. So we know a little bit about that parabola. Okay, I'm going to show you on your assignment today some things that you will be practicing. You're going to be stepping through. I'm going to start with this one right here because this page takes you basically every step of what we just did, practicing it. So at the top, we're doing the first step. It says, find the zeros. Where does it cross the x-axis? Here it crosses at, it's kind of blurry on my board. I think that's a -6. and it looks like a -1. So our zeros, this is not an ordered pair, but it crosses at -6 and -1. And you could do the same thing for number 2 and number 3. To find the axis of symmetry, you find the two numbers, you add them together and divide by 2. So our zeros here are 2 and 5. We add them together, divide by 2, and you will find that the axis of symmetry would be at 3 1/2. Oops. I know I could click when I did that. So that would be 3 1/2, or you could put 3 5/10. To find the axis of symmetry, remember we use our -b/2a formula. So we identify, and these are all in standard form. That's nice. So you take the opposite of b, which was 6, and you divide by 2 times a. So the axis of symmetry here would simply be 1. X equals 1. Go one step farther in the next section. It says find the vertex. Before you can find the vertex, first you have to find the axis of symmetry. So first we do the opposite of x, which would be 6. 2 times a, 2 times 3. So again, our x is equal to 1. And then we plug that back into the equation in order to find what our y would be. And then we will get our vertex. So that just leads you through the things that we have been talking about. On this other page that you can practice on, I'm going to look specifically down here at the bottom. Up here in this middle section, you're doing the same thing. You're going to use your -b/2a to find what your x is equal to. And then you're going to plug the x in order to find y. And then you will have your ordered pair, your vertex. Let's see how this is used in the real world down here. Now, when you have a parabola, the zeros are important and the vertex is important. This has an example. If an object is thrown upward, you're going to have a parabola that starts and it's going to go upward and then it's going to come down. So we know that this vertex at the top is going to be the maximum height that the ball was. Now, if you notice right here, it says the height is given. Notice that the height is in place of the y. So on your graph, the y-axis would be the height because that is what we're using in place of y. And it says t is the time. So we're using t in place of x. X-axis is going to be time. So we know that the time is going to be on the x-axis. The y is going to be on the height. So when we define the zeros, or when we find where it crosses the x-axis, that's going to be 0 seconds when it took off. But what is this other 0 going to tell you? It's going to tell you when the ball, how many seconds it took for the ball to land. So the vertex is going to tell you the maximum height, and the 0 over here is going to tell you when the ball landed. So all of these numbers are important. So when it says Zen throws a ball upward with an initial velocity of 64 feet per second, the ball is 5 feet above the ground when it leaves Zen's hand, and how many seconds will it take for it to reach its maximum height? So let's think about what we've been learning. We've been talking about finding the axis of symmetry and finding the vertex. So to find the axis of symmetry, let's see, we got to plug in some numbers here. So what do we have here? He says that it had the initial upward velocity of 64 feet per second. So where do we plug that in? It tells you up here that the v is for velocity. So here's the v in the equation. So in place of v, we're going to put 64. The ball is 5 feet above the ground when it leaves his hand. Well, notice here that c is the initial height. So in place of c, we put 5. It told you what numbers to plug in. So now your equation is -16t squared plus 64t plus 5. All you had to do is plug in 64 and 5 to that equation. Now you can use your -b/2a to find your axis of symmetry. Once you find your axis of symmetry, you can plug it back in to find your vertex. And that height, that y, is going to tell you how high it is, whatever the height here is on the y. So that leads you through the process. So use what you've learned to try those and then check it on your key. And good luck with quadratics.